This is Algebra 1, Lesson 6-4, Graphing Systems of Linear Inequalities. This is kind of a weird one because we're doing inequalities, which means we have shading to do. Let's first talk about symbols, and then we'll jump into some graphs. So let's talk about our symbols. If I have symbols like a less than or greater than, just reminder that those are going to be dashed lines. So I'll say dashed lines. Do I need to say dashed lines? No, I think that's good enough. It's going to be a dashed line, and if I have symbols like less than or equal to or greater than or equal to, then that's going to be a solid line. So those are the difference. So let's give you an example. In fact, I can move these guys up right here and say example 1. Example 1. What do the instructions say over here? They just say sketch. So I'll say sketch the following. Making up some random problem. Let's do like y is less than 2x minus 3, and the other equation is going to be like y is greater than or equal to negative 1/3 x plus 1. So you just graph. Thanks, Riley. I'm recording a video though, bud. So in these slope-intercept form where you have the y by itself, just pretend that this is an equal to sign. Graph our y-intercept of -3. So y-coordinate, whoa, my hand's messing this up. A -3 is going to come down here to this -3, and that's going to be my first point. And then this is telling me my slope. It's not technically a slope yet, so let's make it a slope. Now it's a fraction. 2/1, all right, off to the side. 2/1 is the same thing as saying 2 up and 1 right. So from our point down here, I'm going to go 2 up, 1 right, 2 up, 1 right, 2 up, 1 right, and just continue that pattern over and over. It's nice to have a lot of these points so you don't make a mistake. See, like that. 2 up, 1 right, 2 up, 1 right. If you keep doing a lot of them, you're less likely to make a mistake on your actual graph. Keep going, keep going, keep going. Have as many points as possible. Cool. So there's that line, and I'll go ahead and now decide, is it a dashed line or is it a solid line? Check out the symbol. There's no equal to sign, which means you can't be equal to it. And we say when we're not equal to it, it's a dashed line. Let me do my best artist's representation of a dashed line. Dashed line that goes through those points. Dashed line that goes through those points, and it goes forever that direction and forever in that direction. But we're not done because we need to say where the solution is. Is this point right here a solution? Is that a solution? Is that a solution? I don't know. Well, first of all, anything that's on this line is not a solution. That's what it means to not be equal to. But is this point a solution? I think it might be, but you have to test. And while the slope-intercept form is kind of nice because you can use these in terms of the up and down direction, whenever we have standard form, it's not as easy. So my general advice to test for shading, and I'll write this down as well, for shading, do a test point. Do just one. You only need one test point. Hold on, bud. Okay. All right, thank you, bud. What I mean by that is choose something easy. I think the easiest point on this graph is 0, 0. That's a nice test point. So let's see, does this point work? If it works, then everything up here will work. If it doesn't work, then everything down there should work. One side works, one side does not. Right, Riley, I'm in the middle of a video. Please stop. So if I plug in 0, 0 into this equation, let's see what happens. I have 0 is less than 2 times 0, and it's hard to see that, isn't it? 2, where can I write this? I can write it over here. 0 is less than 2 times 0 minus 3. 0 is less than 0 minus 3. 0 is less than -3. That doesn't work. That doesn't make sense. So this point right here is not in the solution set, which means everything down here is in the solution set. So I have technology, so I can use a highlighter. If I didn't have technology, I would just kind of do this light. That's my shading just with the line. But because I'm cool and I have technology, I'm going to go like this and shade it with a highlighter tool. And I can make it, ooh, wow, this is going to look really nice. So like all of this area down here is in the solution set. Oh wow, this is going to be a very high quality answer. The highlighter, and nice. I mean, technically, I'm missing the little piece in there, but I'm not that perfect. Okay, then from there, I'm going to graph the next one. So just for clarity, I have colors, so I'm going to go ahead and make you another color. So I'll change the color to, say, green. So when I'm doing this one, again, I'm graphing it. I'll graph it in green. I'll say I'm going to go up 1 on the y-axis. So I come up 1, make a point, and then I use my slope. Again, I have this negative out front. I'm going to make it a -1 and then over a +3, which means go 1 down and then go 3 right. So go 1 down, 3 right, 1 down, 3 right. So 1 down, 3 right, 1 down, 3 right, 1 down, 3 right, and have as many of these points as possible so you don't make any mistakes. All right, I think that's all of them. And then I ask myself the question, should it be a solid or a dashed line? Well, I have an equal to sign here. So equal to sign means I can be on the line. I have a solid line. So I can just hold down. I can hold down with my pen. It should make a straight line with my technology. Hold down. There it is. And there's my line for my green equation, and it goes on forever in each direction. And the question is, which side do you shade? And again, I'm going to do a test point. I really like plugging in 0, 0 or some easy number. So let's plug in 0, 0 into this equation and see if it works. So I'm going to have, instead of y, I'm going to have 0 is greater than or equal to -1/3 of 0 plus 1. And that's going to be 0 is less than or equal to 0 plus 1. 0 is greater than 1. Or equal to 1. 0 is not greater than 1, so that is sad face. This is not in our solution down here, which means if everything down here is not in the solution, that means everything up here has to be in the solution. So I go ahead and I'm going to see if I can get a highlighter tool and change the color here to, all of these different colors. Is this the same green? It was good enough. Add to presets. Is it gonna... Oh, I added it a bunch of times. Let's see how this looks. So everything above here is in the solution set. Okay, it's not the same green. But everything up here is in the solution set. Again, if I had a piece of paper and pencil instead of this digital paper in front of me, I would be doing a bunch of lines up here. And there's my solution set. And you'll notice that because I have technology, there's really only one area that is the answer. And it's technically this area right up here. That is the only solution. It's where there's double crossover. It was lightly shaded here, lightly shaded here. So what would theoretically happen when you're doing your shading on your graphs, you'd have like lines coming down here, and then you'd have lines coming up here, and then you'd see like, oh, whoa, there's like this double crossover area. So that means that the answer is like up in this area up here. And that is exactly the answer. And the way that you show that is just like with extra shading, like make sure that this area is really, really shaded. Say any number that you choose right here will satisfy both this inequality and this inequality at the same time. And that's how you do. I don't want to show those lines though, because it looks better with just the colors, I think. Let me do one final example where instead of doing slope-intercept form, I'll do something in standard form so you can see why it's so important to plug in a test point to see if your shaded area works or not. So do I have enough room down here? I think I do. So let's go ahead and insert another graph. Is that going to be, I'm going to make this a little bit smaller so that it fits. That's going to be off the graph. What to do? I guess I can just use another piece of paper, right? Here, so let me come up here. I'm going to move you right there. And I'm going to insert a graph right here. All right, so in this example, I want to we'll call this example 2. Example number 2, and I want you to sketch the following. Let's do a red equation, which is going to be 2x plus 3. Let's make it a minus. Minus 3y is greater than 6. And at the same time, let's also sketch 4x plus, let's do 3 y, and I want to make that one less than 12. All right, so how do we graph these, first of all? For our red graph, again, the idea is we ignore this, and I basically have 2x is equal to 6. Again, pretend that this is an equal to sign, and I would divide by 2, and I would get x is equal to 3, which means the x-intercept is 3. I come down here to the x-intercept of 3, and I graph a point. Then I do the same thing if I cross off the x. If I cross off the x, I have this negative 3y is essentially equal to 6. Then I'm going to divide by negative 3, divide by negative 3, and that means that y is essentially equal to negative 2, yeah? So I have y is equal to negative 2. I come down to negative 2, make it with pen, and then I just repeat this pattern. Notice that this pattern is right 3 up 2, so I'm going to go right 3 up 2, right 3 up 2, and just graph a bunch of these points, or left 3 down 2, left 3 down 2, left 3 down 2. And then I ask myself the question, are we a solid line or are we a dashed line? We don't have any equal to sign, so we have to be a dashed line in this case. So I'm going to go do my best dashed line. If I had a ruler, this would be really nice, but there's no tool like that in GoodNotes, unfortunately, that I know of. And then I need to do a test point. Again, I love doing a test point of the origin 0, 0. So I'm plugging 0 in there and there, and I'm going to get 2 times 0 minus 3 times 0 is greater than 6. And then this is going to be 0 is greater than 6, which is not in the solution set, which means you, sir, right there, or madame, sad face. No, you're not in the solution set. None of you are in the solution set, but that means that all of you are in the solution set. So I'll use my fancy technology, and I'll use my highlighter tool to say everything here is in the solution set. That's kind of satisfying. I think if I spent more time to make it look really nice, it could be right pressed up against that line perfectly. Okay, so next we graph. Oh, and by the way, just notice that this was a greater than symbol, and yet we were underneath the line, which is why it's so important to plug in a point, because normally students will say, oh, that's a greater than, therefore it's above the line. That's true when you have a slope-intercept form. It's not true anymore when you have standard form. Is it the opposite of true? It depends on a bunch of negatives. The only way to be sure is to plug in 1 test point. 2 if you want to be double sure. All right, so for our blue equation, what do? We're going to ignore that x, and we get this positive 3y is essentially equal to a 12. If I do that, then I'm going to divide by 3, and y is going to be essentially equal to 4, which means I'm going to come up here to 4 and make a point. That's my y-intercept. Then you do the same thing for the x-intercept. You scribble out the y, and you say, okay, divide by 4, and x is essentially equal to 3. So come down here to x is equal to 3, which we already have, which is interesting. So I'm going to go ahead and put a blue point on top of u. And notice this pattern. We want left 3, up 4, left 3, up 4. Just keep repeating the pattern. And it's going to be off the graph. And then I can go down 4, right 3, down 4, right 3, down 4, right 3. Just have as many points as possible so you don't make a mistake. And we have our points set up, and now I need to decide, are we a dashed line or are we a solid line? Well, we can't be equal to, and if we were equal to, it would be a solid line, so it has to be a dashed line if we can't be equal to. So it's my best dashed line, dashed line, dashed line, dashed line, dashed line that goes through those points. Good enough, good enough. And then I need to do a test point. You know which one I'm going to do. I like the origin. If the origin is not available, choose something that's in the small, like 1, 1, or 0, 1, or, sorry, 0, 1, or 1, 0, or 1, 1. Like small numbers like this make your life much easier. 0 typically makes your life really easy. So check it out. If I do 4 times 0 minus 3 times 0 is less than 12, I eventually have 0 is less than 12, which is true. 0 is less than 12. So if that's true, then finally we get our first happy face, and that means that this point is in the solution, which means blue, just looking at this blue line, everything that this is an answer, which means everything down here is a solution, and I can shade that all in with blue. I can say, okay, go to my highlighter tool. Do I have blue? I do. And I can come and say everything, got a little bit too close to the line there. Everything down here is a solution. And you can already see, as I'm having fun coloring this in with the highlighter tool, where that double overlap is going to be. It's going to be in this bottom little section. Whoa, no, I let go. Oh, if I let go, then it counts as double shading. Oh, that's annoying. So I have to start all the way over? Okay. I want it to look nice, so I'm going to start all the way over. I must have thought that I picked up my Apple Pencil or something. I don't know what happened. Let's get this shaded area in here first before I make a mistake. What? Why does it do that? Oh, man. That's really annoying. Okay, well, you can also just do lines. I'm going to do lines. So that means everything down here is fair game, which means that our final area is this area right here. Anything in that area satisfies both this inequality and that inequality. And the way that you'd show that is you'd like really make sure that this area is nice and shaded in for your final solution. Cool, that concludes the notes, and I'm going to give you guys a freebie. If you're still watching this video, thank you. Here's how you do number 1. I'll give you 2 freebies because you're really paying attention.
They actually did the passcode.
Oh, okay, bud. I'm almost done with this video.
I know, look how fast it's going.
It is going really, really fast, I can see. Here's how you do, let's do number 2 because I have a feeling that some people are scared about the just random y or random x. So whenever you have a random y, that means it's going to be a horizontal line going through -1. The way that I always remember this is the y-intercept is -1. So I'm going to make this one blue. The y-intercept is -1, meaning y-intercept is -1, and it's going to always go perpendicular through that axis, meaning I have a line that goes like this. The problem with doing this line is I made it a solid line when it should have been a dashed line. It's not equal to. So I have a dashed line going in this direction, and I need to do a test point. And there, it's actually funny to do a test point because it's only asking about the y value. So if I do this point right here, I have an x coordinate and a y coordinate of 0. This one has no place to plug in an x coordinate. Look, there's no x right here to plug in, so you don't have to worry about it. You only plug in the y coordinate, which is 0. Is 0 greater than -1? It is. It doesn't seem like it, but like 10 is definitely greater than -1. Therefore, 0 is also greater than -1. This is a happy face. It works. This point is in the solution, meaning everything above here is in the solution. The way that you graph that is you'd say, okay, everything above here is in the solution. You put like lines up here, right? To remind yourself, everything up from there is a solution. And then you graph the next equation. So I'm going to do this one in red. From here, you're going to have a y-intercept of 2, meaning I have my first point. And then you're using this slope as the instructions. If my slope is 3/2, that means I'm going 3 up and 2 right. So 3 up and 2 right is going to be 3 up, 2 right. And I'm running out of points, so I'm going to do 2 left and 3 down. 3 down, 2 left, 3 down, 2 left. And I'm going to connect those with a solid or dashed line. Look, there's no equal to sign, so it's going to be dashed again. So we have this dashed line going through these red points. And then we need to ask ourselves, well, there is a shortcut for whenever you have slope-intercept form, which is if this is a greater than, it's above. So I know that it is going to be above right here, but just to prove it to you, I'm going to do a test point. I'm going to plug in 0, 0. So if I do that, I'm going to get 0 is greater than 3 halves of 0 plus 2. All of you cancel out, and 0 is greater than 2, and that's a sad face. That doesn't belong, meaning that this point doesn't belong. It's not this bottom area underneath the red line. It's the top area above the red line, meaning you're having something that looks like this. I'm trying to show what you would look like when you're shading this in with a pencil, and you'd be like, oh, Mr. Snell, I clearly see that the answer is in this section right here, right? And then you'd shade that section in really heavily, and maybe have like a very heavy pencil and be like, okay, this is the section that you want to shade in right there. That's our true answer spot. Make sure it's like heavily shaded in, looks good. Cool. And I think that's what the backside will look like too for number 2. Look at how that area is shaded in really heavily right there. Cool. Numbers 1, 2, 3, and 4 are all slope-intercept form. 5 through 8 is in standard form. I'm just going to randomly pick number 6. So number 6, I'm going to make this equation green. I'm going to make this equation blue and see what happens. So again, the way that we do these is you kind of ignore the y and you say, okay, the x-coordinate is equal to 1. So we have an x-intercept of 1. And then, ooh, this is supposed to be green though, isn't it? And then I'm going to hide the y. I already did that, so now I'm going to hide the x. And the y-coordinate is also 1. So I have those 2 points. And I continue this pattern of going down 1, right 1. So I'm going to go down 1, right 1 again, and keep continuing the pattern, down 1, right 1, down 1, right 1. And you can see that it's this diagonal pattern that just has a slope of -1. Notice that we have an equal to sign in this case, so we're going to have a solid line going through these points. There it is. Arrow, arrow, and then I need to do a test point. Does 0, 0 work? I'm testing this point right here, the origin, plugging 0 into both the x and the y. Is 0 plus 0 greater than or equal to 1? Is 0 greater than or equal to 1? And you will say, no, sad face, 0 is not greater than or equal to 1, meaning that this point right here is not in the solution, but that means everything above here is in the solution. So the way that you do that is you just put a bunch of lines up here saying, hey, everything up here is in the solution. From there, you need to graph x and kind of like equal to, I guess, -2. So on the x-axis, I'm going to come over here to -2, and I'm going to make my point here and say, okay, it always runs perpendicular to the axis that it runs through, so it's going to be this line that goes like this, and let's go ahead and make that. There's my blue line, and it is a solid line because I have an equal to sign. So is it to the left or to the right? You can kind of guess. It's less than, so it means to the left, and you would be correct, and here's why. What if I plug in 0, 0 again? If I plug in 0, 0, you'd be saying that 0 is less than -2. Well, the only thing less than -2 is -3, -4, anything to the left of that. So sadly, 0 is not in the solution set, meaning everything over here is in the solution set. So your answer is going to say everything over here is in the solution set, and the only little overlap is in this tiny little triangle up here. And that's the way that I'm going to shade this in. I'm going to come back here, make my line kind of thick, and say, hey, that's the solution, is just that triangle. And then we'll check our work for number 6. Check our work for number 6, and you can see, yep, it was just that little triangle piece up there. That's all I'm going to give you for the video for today. Thanks for watching the lesson 6-4 in graphing systems linear inequalities. I'll see you guys later.